And we'll kick it off now. Hello, everybody, and welcome to Western Alaska Minerals live presentation and Q&A. I'm Vanessa Bogart, Director of Corporate Communications and IR, calling in from Vancouver, BC. Thanks for joining us today. Today, we're going to be talking about Waterpump Creek and how quickly and consistently WAM has created value by delivering exceptionally high grades plus widths over the past 2 drill seasons in this area of the system. Most recently, compelling drill hits with the quote-unquote barbecue rock 700 meters south at Last Hurrah have amplified the team's excitement. There will be forward-looking statements in this presentation, so please visit our website for more information. Today's program will begin with our co-founder and CEO, Kit Mars, coming to you from Talkeetna, Alaska, who will briefly guide us through WAM's investment thesis and near-term catalysts. Also joining us today is our VP Exploration, Andy West from Juneau, Alaska, and Sage Langston Stewart, our project geologist from Denver, Colorado. Both Andy and Sage will take us through a high-level CRD technical talk, and that should all take about 30 minutes. And after that, we'll open up the Q&A via the chat box. That's the little button in the bottom right. All right, take it away, Kit.
Okay, well, thank you very much, everybody, for joining us today. And as Vanessa said, I'm with you from Talkeetna, Alaska. So we'll be moving ahead. First, just want to point out this is an aerial view. Many of you have seen this, but of the area we're working in, our camp in the right foreground, the large Illinois Creek airstrip in the left. And just off the screen to the left would be the trace of the Waterpump Creek and Last Hurrah zone just to the left or to the east of the airstrip. So everything is very close in, and it's a good place to work. Easy to build roads and drill in, a little tough to explore, not too many outcrops. So let's go ahead and move ahead, Vanessa, please. So here is the forward-looking statement. You can check that out, as Vanessa said, on our website. So very proud of our discovery management and technical team. As Vanessa said, I'm co-founder of the company. My wife, Jonah, and I founded the predecessor, Western Alaska Copper and Gold, in 2010. But from a technical standpoint, I was the first project geologist to working for Anaconda Copper Company in the 1980s to manage this project. So Andy West is with us today, so he'll introduce himself a little bit later. Sage Langston Stewart will be giving part of the presentation. Want to mention Joe Pekenbrock, our Chief Exploration Officer, is not on the call today. And also, very importantly, Dr. Peter McGaugh, really the world's leading expert in carbonate replacement deposits, has been working with us the last several years, been on site twice, and we all work very closely with Peter, fine-tuning our exploration details. Next slide. So a couple points I'd like to make. We're very proud of our community support. We've been working very hard on a local hire effort since 2016. In the villages of Galena, Caltag, and Nulato. On the right is a picture of some of the folks from, I believe this is from Galena. So this year we had visits from all of the villages I just mentioned, and the goal is to bring out the tribal leaders and everyday citizens to get familiar with our project, where it is, exactly what we do, and also very importantly to see the jobs we've created for the members of their individual villages. Next. A little bit of our location, Western Alaska. This slide is just to show that we do have deep water access by ocean-going barge from the Pacific Northwest, can go through the Aleutians and up to the mouth of the Yukon River to where it's shown there. The red pin drop is our location. So the proximity to the Yukon River is very important. As you'll see in the next slide, we're only about 28 miles off the river, and there's a picture of the Yukon River in the lower center. It's about 1.5 miles wide at this point, 45 feet deep, and during the summer there's a river freight barge about every 7 to 10 days going by. Airstrip is very important for our ongoing support of our exploration efforts. 4,500 feet long, and the last 2 years, we've started using large, heavy lift C-130 Hercules aircraft because that's really the most cost-efficient freighter used today in Alaska from Linden Air Cargo, and it really brings the transportation and freight costs down. While we have this slide up, if you're looking due north up the runway, and the Waterpump Creek deposit is just about 2 kilometers due north along the runway down in the creek. And the last draw trend is trending towards the camera, and we're drilling just about a kilometer or so off the end of the runway. Next. So we have a very fortunate to be in Alaska, which is really one of the world's leading mining jurisdictions. All the claim groups you see here and the thin red line, which is our proposed river access route to the Yukon, all of those entities or properties are on state of Alaska land. State of Alaska is our primary regulator for permitting and other activities. We have a total of 5 properties, 73,000 acres, all on state of Alaska land, 100% owned. So we don't have any third-party royalties or other interests. The 5 deposits we have are shown there on the left, but we'll be focusing on the 2 gold stars, the Illinois Creek past producing mine, which is shown in the center of the Illinois Creek claim block, and about 6-7 kilometers to the northeast is Waterpump Creek. This is all one big geologic carbonate replacement system, so I do want to just touch on that, and that is gives a little bit of sense of the scale of what we're working with. In 2021, as we were stepping out doing some exploration around the Illinois Creek past producing mine, we touched on and wanted to continue some work started by Anaconda Copper Company back in the 1980s, and they made the original discovery, surface discovery of the Waterpump Creek, very high-grade lead, zinc, silver deposit. But very little was known about the sulfide component below the surface oxidation. We drilled 9 holes in 2021, and hole number 9, the core is shown on the left. And that is a spectacular 10.5-meter intercept of very high grade, over half a kilo silver and 36-37% combined lead zinc. So really one of the takeaways here today is the high grade of Waterpump Creek. The high grade makes a small tonnage still very valuable, a lot of metal content, low footprint when you're planning a mine. This would be an underground mining operation. Low footprint means a low environmental footprint, and also, very importantly, low capital costs. So those are some of the key takeaways. Next. So really the opportunity set is exceptionally high grade. Pictured here on the left is some of the what we become very well known for is the wavy argentiferous galena. Very unusual to have so much silver in the galena crystals, and that's shown as it weaves through the rock on the left. In the center is the darker is the sphalerite, which is zinc mineral. All the lead is contained within the silvery galena. So ultimately, this property would produce 2 concentrates, a lead concentrate with all the silver, a zinc concentrate with the zinc. And I just want to point out, very similar both mining technique and the production of concentrate that you see today from Hecla's operation at Greens Creek outside of Juneau, Alaska. And when Andy introduces himself, he can mention that a little bit. But it's very similar, and it just shows what the end product will be. Next. So real quickly, the carbonate replacement deposits have not been well known lately. Most of these were mined in the domestic lower 48 and Mexico about 100 years ago. 2 of the most famous are shown on the left, Santa Eulalia in Chihuahua, and the Tintic District in Utah, which is just south of Bingham Canyon. The takeaway here is 2 things. One, the scale. All 3 of these maps, including ours on the right, are all at the same scale. There's a little kilometer bar in the lower left of the large map, and it shows that we really have a deposit on the similar scale as the 2 most famous in the world. The second thing is the long skeletal finger nature of the mineralization, and so that's the key to exploring these deposits. Upper right hand of our larger west block shows the distal lead, zinc, silver, the red chili pepper that represents Waterpump Creek. And I just want to point out that is about 8 kilometers to the northeast from the past producing Illinois Creek mine. Illinois Creek provided our going public resource in 2021 of 525,000 ounces of gold equivalent. So that's where we started. We are now focused, obviously, on Waterpump Creek. Again, this is all one big geologic system. So that's very important from a scale standpoint. Next slide. So we've talked about the high grade, and very importantly, to go along with the high grade is we have excellent widths of the mineralized intercepts. So somewhere between is 10 to as much as 100 meters. So very unusual for this type of deposit to encounter those very large grades. This graph just shows on the left, or this the weighted average of the various intercepts, and on the bottom is the average width of drill intercepts for the best known CRD deposits in the world. You can see that Western Alaska's Waterpump Creek deposit is right in the sweet spot in the middle, and that just tells you that it's really a high value proposition because you combine both grade and width, which allows for very efficient underground mining. Next slide is won't go through all the points, but I mentioned Peter McGaw and his leadership in understanding carbonate replace deposits. He has a checklist of 12 items. You can see that we checked just about all of those, and we're working on the others, such as number one, location. We have a number of other areas in the district that we feel are carbonate replacement deposits, and so that will ultimately make our district place it on Main Street from a CRD standpoint. Our share structure and capitalization is shown here. We have a very simple, clean share structure. On the right, ownership is divided pretty much equally between 1/3 directors and insiders and officers of the company, including the founders, Joan and myself. About 1/3 of institutions, very proud to have Crescat Capital out of Denver, Commodity Discovery Fund out of the Netherlands, and Delbrook Capital out of Vancouver as some of our institutional blue chip shareholders. The other 1/3 represents our retail ownership over the last couple of years since we've gone public. Have about 49 million shares that would be counted towards capitalization. So that number fluctuates with the stock price. So last month that was in about 128 million, and that is based on a fully diluted share count of 55.3 million. So I think at this point, I do want to mention our two analyst coverage, Michael Gray at Agentis and Mike Niehauser from Roth Capital. Both are providing coverage for Western Alaska Minerals. So at this point, I think I'll take a look at the next slide. We'll be turning it over to Andy. This is the district size map and geologic map, and like to introduce Andy or have him introduce himself and then turn it over. Please go ahead.
Okay, thank you, Kit, and thank you for everyone for joining us today. And certainly we do want to share essentially our exploration program for this year and the successes we have, but also to give you a good understanding of the overall exploration potential that we have for this, CRD system within the Illinois Creek mining district. And I've only been with Western Alaska Minerals for since April, and I came over from the Greens Creek mine here in Juneau, Alaska, which is a world-class VMS deposit, one of the richest silver and gold deposits, or at least VMS deposits in the world. And most recently from Ambler Metals, which is a little bit north of Western Alaska Minerals, in the Brooks Range and the Ambler Belt, where they have two world-class deposits. And what really attracted me to WAM was the potential here, which is really on the equal of those two other districts, and really one other mine and two other potential mines. And so just to share that with you is on this slide here, as Kit also described in pretty good detail, is that we are blessed with this really large land package that hosts at least two CRD deposits, or two systems. One is the Illinois Creek past producing mine, which Kit mentioned. And so that still hosts our recently disclosed or current resource that is over 500 million ounces or 500,000 ounces of gold equivalent, and that does include the 13 million ounces of silver. So still very silver rich oxidized deposit. And along that same area of what we call the West Block, we have other numerous gossans, other occurrences and targets that are certainly on our radar screen for exploration work. However, over the last 3 years, we've been really concentrating on the East Block, which was basically working on the original discovery of Waterpump Creek by Anaconda, and then from that, and for this year, stretching that exploration effort to the last hurrah target, which is across the Illinois Creek Fault, which has been lightly explored. Certainly, a few holes by Anaconda and a few holes by Nova Gold back in the 90s. But this really is, all told on this East Block, we have over 6 kilometers of really exploration potential within those carbonate rocks. And so that's obviously a very large area to explore, and that really keeps us and the geological crew excited every night when we go to bed to wake up in the morning and start working on that area. If you want to go ahead into the next slide, please. Certainly discuss some of our goals for our 2023 program. At Waterpump Creek, it was to complete an infill and step out drill program. And basically the goal of that program was to certainly expand the resource to the south, which is what we did, and then also to get sufficient drill density within Waterpump Creek so that we could have our initial, start working towards an initial or maiden resource estimation for Waterpump Creek. And of course, that will really depend on the timing and results of those will really be a function of our QPs and our resource estimator that we are working with to define that resource or to calculate that resource. And so, certainly our goals there are to, have an inferred mineral resource at some time in the future, and to certainly define, knowing the high grade deposit that we have there, is to certainly have, over 100 million ounce or 120 million ounce at some point silver equivalent resource that we can talk about. For the last hurrah drilling, we stepped across. Okay, yep, thanks, Ruan. Do the next slide. So certainly for the last hurrah, we stepped across the Illinois Creek fault there that divides, that, has a truncates, or we believe truncates, the Waterpump Creek deposit. And then to the south of it, we have a large area of exploration potential within the carbonate sequence that again was lightly explored by Anaconda in the past. However, this year we went ahead and drilled 4 drill holes across a section almost 500 meters in length. And so that goal was really to define basically the stratigraphy, and then to really detect any sort of alteration patterns, either geochemical, visible alterations such as sanding, and then also looking at UV fluorescence, which is one of the main tools that have been used on other CRD deposits, really to target in on mineralization. And so that is where we really had our success this year. And then to really turn it over to, or I'll turn it over to Sage, or first of all, we'll queue up a video that really describes the success that we had along last hurrah drilling this year of those 4 drill holes.
I'm Sage Langston Stewart, a project geologist with Western Alaska Minerals. Today I'm going to talk about the most recent press release discussing the extension of mineralization at the Waterpump Creek silver lead zinc carbonate replacement deposit and the drilling results at the last hurrah prospect. For those of you who are unfamiliar with WAM, we are located in west central Alaska, where the red pin is on this map. I'm just going to dive right into the Illinois Creek District. This is a geologic map of the Illinois Creek District with the historic gold, copper, silver Illinois Creek mine highlighted, and the location of Waterpump Creek and Last Hurrah, which is what I will be discussing today. Zooming into Waterpump Creek, we've completed 5 infill and extension drill holes this summer, which are shown in blue on the map here. The highlight of this release is drill hole Waterpump Creek 23-30, which cut 71.6 meters of multiple sulfide zones and extends the Waterpump Creek mineralization 45 meters to the south, bringing the total strike length to 495 meters. Check out the table in the press release to see those grades. What I really want to talk about today is the drill results from last hurrah, which is about 700 meters to the south of Waterpump Creek mineralization, which is shown on the map here. D to D prime is the profile of 4 drill holes completed this year at last hurrah. Taking a look at the cross-section, all 4 widely spaced drill holes intersected real significant alteration, including sanding, bleaching, recrystallization, tan alteration, and UV fluorescence. The most exciting intercept comes from last hurrah 23-0005, which intersected 21.4 meters of strongly fluorescent barbecue rock. According to the world-renowned CRD expert, Dr. Peter McGaugh, this barbecue rock is a proximal exhaust feature of CRD mineralization. So let's take a look. This is the impressive fluorescence that indicates that we're really close to something. Taking note of the complexity, multiple different textures including breccias and veins, there's yellow, orange, and even pink UV fluorescence, which corresponds to anomalous lead and zinc values shown by the handheld XRF analyzer. And as Dr. Peter McGaugh says, complexity itself is a vector. So what exactly is the importance of this barbecue rock? Well, let's compare that to Waterpump Creek 22-21, which is another occurrence of barbecue rock seen at Waterpump Creek. When Waterpump Creek 21 was drilled last year, we saw this bright orange fluorescent barbecue rock, and that was our indicator that we were close to mineralization. So we took a 30-meter step off and intercepted the high-grade mineralization and drill hole Waterpump Creek 22-22, which refer back to the previous press releases to see those grades. But just comparing the textures, colors, and intensity of these 2 drill holes, we can say that last hurrah 5 is very similar to Waterpump Creek 22-21, and we've got to be close to mineralization. So just putting this into a little bit more context, the last hurrah drilling profile is 700 meters to the south of the known mineralization at Waterpump Creek. The 2 cross sections on the right are drawn at the same scale. So here's the fluorescence in Waterpump Creek 22-21, just 30 meters away from the mineralization in Waterpump Creek 22-22. The ore body at Waterpump Creek is 30 to 75 meters wide. And each of the drill holes on the last hurrah profile are 120 to 130 meters spaced. So we see alterations spanning across the entire section, which is something around 350 to 400 meters of significant alteration. This large-scale alteration halo at last hurrah demonstrates that multiple pulses of hydrothermal fluids affected the zone, and it's a good indication of the size of the system. We are very excited to test this amazing target delineated by the barbecue rock and the opportunity to expand our known mineralized footprint. Thanks so much for listening. Alrighty, thank you all. So the key takeaways really from last hurrah is that, we've drilled this profile. There's really significant alteration across the entire profile. So we're talking 350 to 400 meters of significant alteration, which is, sanding, tan alteration, bleaching. So a big alteration footprint, which is very exciting. And our drill hole last hurrah 5 really makes us believe that we are honing in on mineralization, and we have intercepted what we are considering a bleeder, which is an exhaust from the system. So we know it's a bleeder because of the UV fluorescence in combination with the handheld XRF spot data. So the numbers really speak for themselves. We've never seen 0.5% lead values from the XRF fluorescent veins before. In Waterpump Creek 22-21, which was only 30 meters from mineralization, it had a highest value of about 0.2% lead. And in last hurrah 5, we see about 0.48% lead in the handheld XRF analyzer. So the importance of the lead itself is that lead is relatively immobile. So just thinking of that, let's think of like a bus analogy. So all of the elements hop on the bus in the center of the city at the main bus station. All the elements hop on. Think of this big bus station in the middle of the city as like your heat source or potentially your porphyry. So as the bus goes out from the city, all the elements are going to get off at different spots. So the gold and the copper, they live in the inner city, so they get off almost immediately. The silver is going to get off kind of maybe towards the edge of the city. And then you have zinc, which likes it out in the suburbs. And then you have manganese, which likes it way out in the farmlands. It might even have to walk a little bit farther at the end of the bus stop. So that kind of gives an analogy for the overall metal zoning. And so the fact that we see lead in this vein with the fluorescence, we see pink, orange, and yellow fluorescence, and the lead in the XRF analyzer in a small scale vein really indicates that we've got to be pretty close, because lead likes to live, within the city. It's not way off in the suburbs. It's way not off in the farmlands. It likes to live just on the extents of the city. So seeing those lead values was really exciting, and just all the crazy different fluorescent textures where we see breccias and veins, and all the different colors that we see. So those are all very exciting, and that's a close-up right there of the bleeder itself. So notice how the bleeder is actually darker in color and actually doesn't fluoresce, and that's because the main zone there actually has, let's see, what is it, 5% manganese. So it's full of manganese, 0.5% lead, and about 0.2% zinc, which means that really is within the zone. And the fluorescence, what causes it to fluoresce is really trace amounts of, zinc or manganese. So that's really trace levels kind of emanating off from this main bleeder zone. So we see the bleeder zone, we see it on a large scale. We see that, in Waterpump Creek, which is where we have a lot of information, we see this fluorescent halo really close, 25, 30 meters away from our main mineralization. So at Las Terras, taking what we know at Waterpump Creek, applying that to what is a little bit more unknown at Las Terras, and seeing the fluorescence, it's a really good sign, and we're all very excited about it.
Thank you very much, Sage. That's excellent insight and context as to what we've found so far in a short period at Las Terras. If the technical team or Kit have any other comments, we can now open up on time, I'd like to say, the floor to Q&A. And we do have a few questions already in the chat box. Okay, I'm going to ask the first question. I'll volley this one over to you, Kit. Will the placement be fully subscribed? Also cash position prior to money raise?
There, I'm now unmuted. So we're very close to making that announcement. We'll be making a decision in the next day or two. So very, very pleased with the reception of the private placement to date, and the cash position that I can quote based on our June 30th financials. So that's the only one that's currently public. So we can't do any selective disclosure. That amount was 2.9 million cash and another 300,000 to 400,000 in receivables. So I can, hopefully that answers the question.
Thank you, Kit. Next question. Do we feel we have achieved our tonnage goal at the Waterpump Creek deposit?
Well, I'll comment on that. So the goal that was on that one slide that Andy was talking about was really a goal for the ultimate goal for the combination of Waterpump Creek and Las Terras. So we have a very good idea of what we know currently at Waterpump Creek. And so that information actually was handed over earlier in the week, and I'll let Andy comment on this as soon as I stop, but that to our third-party resource estimators. I don't want to guess at any numbers because that's their job, but we're very comfortable with what we've seen. And in addition, we hope for the first time to take a look at the historical oxide, which is very silver rich up at the top. So Andy, if you would like to maybe add to that.
Yeah, there's probably not much to add. Kit, I think you answered it very well, is that, we'll really have to see what the QPs come up with and to see what our total tonnage is. But certainly that goal is, a longer term goal also for Waterpump Creek and Las Terras. And I think it's also important, we are stepping off to Las Terras, that's where we see where the bigger prize is. But there still is exploration potential to the north, and then further, actually a little bit, certainly some infill drilling to the south and southeast of our whole 30 that we had the big intercept on this year. And so there's still chances to add incremental tons to the Waterpump Creek deposit itself. But certainly Las Terras is really where the big prize is, and when we can really, really add to our resource, our potential resource.
Thank you, Andy. Okay, I think that we have the next question here. How far have you stepped out on Waterpump Creek? Are you still planning on stepping out to 1,000 meters? Do the geophysics not support the further extensions of Waterpump Creek?
So I guess, Yeah, maybe to answer your question, certainly the Waterpump Creek is, we know that there is a fault offset along the Illinois Creek structure or fault. And so there's still some drill holes that we want to drill to better define exactly where that offset is and to fill into the south. So there's a little bit of potential there. And our step-off drilling was 700 meters in last hurrah for that section that we drilled. And certainly there is potential much further to the south, that we could step up, certainly quite a way. So, really last hurrah is still wide open for exploration drilling and for extensions of the CRD body that we see at Waterpump Creek.
Yeah, if I could add to that, the geophysical target that we talked about earlier in the year was based on some 2005 IP work, and that anomaly was about 1.5 kilometers long, but that was limited by the end of the survey. We did a very extensive 3D induced polarization survey this year. It was collected a huge amount of data, and so the data size surprised both us and our contractors. So we've just completed in the last week the first pass modeling of that, and the interpretation hasn't started. But I would say that the length of the target area at last hurrah is not just the 1.5 kilometers, but it's 3 to 4 kilometers in length, and we will need to do a lot of drill testing along that. It's the structure's there, the geochemistry's there, the geology's there, but this type of exploration is drill intensive. We have 7 holes to date in the last hurrah area that we've drilled. To the north, that small area of Waterpump Creek, there's about 65 to 70 drill holes. So we've got a long way to go. We're just getting started there.
Thank you, Kit.
I also just want to add a little bit for clarity that essentially everything on the east block and the west block as well, it's all one system. So the terminology of Waterpump Creek and Last Hurrah, it's all one continuous mineralization zone. It's just been offset, and so we've just called everything north of the actual Waterpump Creek, and stuff to the south of the actual creek, Last Hurrah. So it's really Last Hurrah and Waterpump Creek are one continuous mineralization body.
Thanks,
just for
Nate.
clarity. Yeah,
that's helpful. And I love what's the namesake of Last Hurrah, because it's really our first hurrah here.
Yeah, I'll just comment on that. So 1984 was when the first drilling occurred at Waterpump Creek by Anaconda Copper Company. That was after 2 years of extensive follow-up and a lot of geochemistry and mapping. And so they defined this zone to the south from the geology and the very striking lead, zinc, silver anomalies in soil, planned an extensive drill program. The company was closed that winter due to low oil prices, and so therefore it was called Anaconda's Last Hurrah target. They defined it, identified it, but never were able to drill it. So you can see on this map, and maybe I'll let Andy and Sage talk about the soil geochemistry because it shows how big the system really is. Andy?
Yeah, certainly. I mean, that's the big takeaway is, and also from Sage's comments, that this is really one big system, and that we're just starting to really get our hands around it, especially on the last hurrah. And probably one of the important things to mention from the soils is that the soils tend to be leaking along one of the major thrust faults in the area. And so some of those soil anomalies, particularly on the east block, are actually offset from the mineralization.
Thanks, Andy.
But certainly show the overall continuation of the system.
Yeah, and you can see from the relative size of the soil anomalies that the smallest one is actually Waterpump Creek. The middle size is the Last Hurrah area, and the largest is over the past producing mine. So I do want to point out, I forgot to mention it earlier, but the fact that the Illinois Creek mine was a fully permitted, fully operational, open pit gold silver mine shows that this is really a brownfields exploration area with a past producing mine that is on the site. So Sage, you'd like to add anything to the zoning?
No, I think that it's pretty good. I mean, there's the gold and copper, which are the bottom two, which are really around Illinois Creek. So back to the bus analogy, gold and copper at Illinois Creek and a little bit less so at Waterpump Creek and Last Hurrah. But at Waterpump Creek and Last Hurrah, we have our more lead and zinc vectoring alteration halos, essentially. So we see their lead and zinc at Waterpump Creek and our gold and copper at Illinois Creek. And we believe the whole thing is tied together. Just puzzle piecing that back together is what we're really currently working on, and putting together all the pieces where we haven't yet explored. We kind of have two end members where we have Waterpump Creek, the little fingernail, and then Illinois Creek somewhere along the way. So connecting the whole system.
Thanks, Sage. Actually, that leads into how much more drilling can you afford to do this season, and where will you do so? I think we kind of covered that over in this previous map. Excuse me.
There's a couple of questions along that line. So I guess, certainly for our drill program going forward for this year with the financing, is that it'll be mostly following up along, or will be all in Last Hurrah and following up along where we think we have very proximal indicators along hole 5. And so our planned drill hole shown on this section here will be about a 50-meter offset to the east from 5. And then certainly the other additional drilling will be certainly informed by the results from this hole, but most likely be either following that along strike to the north or south, or potentially moving to the west side of 005 and then testing basically up dip along the main controlling structure. And so, we're looking at having, 13 to 1,500 meters more of drilling for this year. And really, one thing that certainly dictates when drilling will end would really be the weather in Western Alaska, as it certainly gets to be colder and darker and becomes more expensive to keep the drills turning.
Yes, thank you, Andy. Next question, how many of the planned tasks, there was a list in the presentation, will get covered by the recent financing? And I guess I'll hand that one over to you, Kit. We're still in the financing, so I think we have to be...
Sure. The 4 exploration holes that are shown here in the second line down, so those have been completed. As Sage and Andy mentioned, hole 5 showed us the strongest evidence once all the logging was completed and analysis. So that part was completed, and the additional drilling that will result from the current financing will drill those 1,300 to 1,500 meters, 3 to 4 holes, depending on their depth. We have completed the road access study and costing that was done a few months ago. Metallurgy is underway, and we'll be doing some more extensive metallurgy. So some of the funds from the current financing will add to and increase the metallurgy, and some of it will also fund the resource study that started this week. A lot of the baseline studies have been completed. We're not doing any more this year. There'll be some follow-up next year.
Great. Thank you, Kit. Try not to jump around too much. We have questions relating to the stocks as well as technical questions. I'm going to ask Kit, can you speak to the liquidity of our trading, of WAM's trading?
Okay. Well, very good question. So we've only been public still less than 2 years. So liquidity has been growing, but it's still lower than we would like to have. One reason for that is really about a third of our shares to insiders, directors, founders is still tied up and restricted due to our foreign private issuer status. So those shares are not actively traded. And a lot of our larger institutional shareholders and investors don't trade on an active basis. So liquidity is low. It's been ranging from 7,000 or 8,000 shares a day on the low end to 90, 100,000 on the high end. As we complete the financing, that should increase. And then in this winter, we'll take a look at an OTCQX listing to help the liquidity there. And it'll just take time. So that's where we stand on liquidity. Ultimately, we would hope to have a U.S. listing, but we don't have a date for that just because of the cost involved right now. We want to spend that money on drilling.
And speaking of drilling, Kit, what is our average cost per meter or cost per drill hole?
In the past, the number we've used is around $800 a meter. That sounds high. It's on the high end, but that includes everything other than our corporate officers and the Tucson office. So everything in Alaska is thrown into that, from the camp, transportation, air freight, drilling, drill muds, geologists, you name it. So that's a true all-in cost, and a lot of people don't factor in everything in that, and we do. We do want to point out one thing that's very different between our drilling and, say, some of the high-grade silver deposits in Mexico. They have some very, very large drill programs. They do a lot of drill footage, a lot more than us, but they're having a lot of intercepts, but they're very thin, and each one produces not that much in the way of tonnage. We have a pretty good success rate, but when we do have a success, and I won't mention hole 18 because that's the best one, but we have a number, hole 17 and others, that are in that 25 to 47 meter thickness. So each one of those drill holes really discovers a lot of tons and a lot of grade. And so that's the difference between the drilling that we have and in other localities. It's the thickness of the intercept and how many tons each one produces.
Great. Thank you, Kit. I think I'm going to pass this question to Sage or Andy. How close of a correlation do you have between the field XRF analyses and the assay return from the lab?
I guess, the main tool, or the XRF, we use that basically for those small scale or very high resolution measurements of the veins that we can use to track the metals in the veins, as Sage described as the bleeder feeder zones to the deposit. So that's the main power of the XRF, and we're not using that really to define what the overall grades of those intervals are. And so it's basically an exploration tool that we use, and we're just taking very small spot samples along those veins. And certainly, we're just getting those geochemical results back from the lab for the last raw holes. And so we'll certainly compare what we see in the, in the 2 to 2.5 meter intervals that we take, compared to the very, the spot samples that we take within the veins. And so obviously that geochemical signature is going to be diluted greatly within that 2.5 meter. And that's why that's the power of the PXRF, is that we can get those high resolution spot measurements that will help us with exploration.
Maybe Sage could point out, she's the one that actually takes these, if you can find some of your little green circles there, Sage, and just describe what you actually do.
Yeah, so thank you for that. Yeah, so the XRF essentially just hold it up, and so each one of those green circles is about the screen size of the handheld XRF. And so one of the things with CRD deposits is that they have really sharp boundaries, and even in our main mineralization zones, you could put your thumb on full sulfides and unreacted rock. So it's really important to cue into the smaller scale structures and what the rock is actually trying to tell us, because that one vein, has 0.5% lead in the XRF, but over the whole sample interval, which is, as Andy said, 1.5 to 2.5 meters, you're not going to pick up on that geochemical halo, especially with the lead. So there is about a 300 ppm zinc halo that is shown from the assays, but really fine tuning and honing in on the smaller scale structures and being actually within that vein, you're in the system, and just outside of that vein, you're outside of the system. So using the handheld XRF to hone in on the finer scale details and be the rock detective and investigating what the rocks are really trying to tell us, and pick up on the clues that will lead us closer to the system. So the XRF, you hold it there, you zap it, has different wavelengths, essentially sends an X-ray into the rock and comes back, and then based on the spectrum and the wavelength analysis, it'll tell you how much of each element is in it, which has been a really, really helpful vectoring tool, which Peter McGaw has advised us to do and actually start tracking that. And it shows, has been really, really helpful in picking drill holes and seeing, it is a very visual deposit. Like when we hit sulfides, we can see those, but for the alteration, it's really helped geochemically define the alterations and halos.
Okay. All right, thank you. So vectors, halos. I've got a question here. You don't expect a parallel system, but you don't expect a parallel system between Waterpump Creek and Last Hurrah on each side of the fault.
No, so we definitely do. So it's all one system, right? So we essentially expect a continuation of Waterpump Creek down to Last Hurrah. It's just been offset by the east-west structure. So as we're moving along Last Hurrah, a lot can change from fluid dynamics perspective over 700 meters. So at Last Hurrah, we're seeing increasing intensity of alteration. So at Waterpump Creek, we don't really see any sanding. We see what I've called bleached and tan alteration, and then some little veins and things. But as we've stepped across 700 meters to the south at Last Hurrah, we're now seeing very intense sanding, which means hotter, more acidic fluids. And we're seeing much bigger size of alteration halo. We still see the soil geochemistry. We still see the geochemistry in the XRF, and we will soon find out about the assay intervals as well. So we do just expect a continuation of that system to the south.
Okay. Thank you, Sage. That's great color.
And Vanessa, sometime if you have access to that picture of the from standing in the pit that shows the white sanding on the pit wall, that's a good example of that.
Mm-hmm. We do at the very end of this.
Once you go through your...
Sure. Flip through here to the very end. We have a little glimpse of the pit. Oops, there we go.
Okay, back there. So just when Sage and Andy talk about sanding, it sounds interesting, but didn't sound like much. So in this is a view looking to the west along the Illinois Creek fault structure, and this is where it's mineralized and what was mined in the 1996, 97. The right-hand side or the north side, the high pit wall, it just looks like a white sand coming down the cliff. And that is the result of the dolomite, which is the host rock to the mineralization that's actually shown in the bottom half of that slide to the left there. When the minerals, the fluids come through, they're very acidic, and they dissolve the cement that holds the dolomite, which is just a manganese-rich limestone. It dissolves that cement, and when you open it up, like in the high wall of the pit, it just cascades down. Peter McGaw coined the term sanding, and this is found in all the best known deposits, CRD deposits that he's worked on. So that's a function of the alteration, shown here 8 kilometers away within the Illinois Creek mine. And that same alteration is recognized by Andy and Sage at Last Hurrah and Waterpump Creek. So
compelling evidence is what I'm hearing here. Thanks, Kit. My next question is, Kit, what are our plans for the area labeled as Porphyry and Warm Springs? So I'll go back to this slide.
I'll comment real quick and then let Andy pick up. So this, again, Sage talked about the gold, silver, copper geochemistry center when she showed you the maps. That would be represented by that green porphyry target. That is a generically placed target. We know it's somewhere in that area. Where it is, we don't know, and how deep it is. But that is what Peter McGaw looks for in this type of deposit. They're all related to a porphyry, but you don't always find that. Tinnick has the porphyry. Santa Eulalia produced 700-800 million ounces of silver, and one was never found. So the Warm Springs target is in the permissive dolomite stratigraphy going off to the north, and that is both from soil geochemistry and from geophysics. And we have 2 little black dots there, and I'll let Andy talk about those that were drilled last year, the Illinois Creek exploration holes.
Sure, thanks, Kit. So yeah, as Kit said, we do have 2 holes that have penetrated into the stratigraphy on the south side of the Warm Springs fault, and that was, one hole was drilled in 21 and one hole was drilled in 22, and certainly both of them show, particularly 2101 shows extensive sanding, and then 2203 just intersected some certainly sanding and some elevated geochemistry before that hole was ended. And so we still see that the same alteration package on the south side of that fault. And that's just, certainly a very high value target. It's just something that in the near future, we'll be concentrating closer to basically the Waterpump Creek or the known mineralized body. And certainly, the big overall target could be, if there is a porphyry that does feed the CRD system, certainly that's also a very valid exploration target. And it'll certainly take a little bit more work to really unravel exactly where that porphyry could be. And certainly going to Sage's discussion on looking at metal zonation as we get more, hopefully, intercepts into Last Hurrah, is that we can have a better developed vector, basically based on the copper and gold to where that porphyry target could be.
Great.
Can I
Thanks.
add just a little bit on the Warm Springs? So the Warm Springs, so we have our Illinois Creek mine, which the manto is dipping off to the south. And so the Warm Springs target was really generated from it being capped by the greenstone. So the idea is that the greenstone acts as an aquitard, similar to how the schist does on the east block. So with the manto dipping underneath our greenstone aquitard, there's a lot of potential for the Illinois Creek manto to be underneath the greenstone and be no longer oxidized, but actually be sulfide. But as mentioned already, we just haven't drilled the holes there just yet. But definitely a really, really good target. And we have a lot of questions about what's going on underneath the greenstone there and the continuation of the system.
So that was one of the questions we had. Sage was, how do we expect Warm Springs mineralization to compare to Waterpump Creek and Last Hurrah? So aquitards, is that what I'm hearing?
Yeah, I mean, another, I think there was another question somewhere too about like the angle of the hole at Last Hurrah and whatnot. So we have two different kind of things going on where we have a closed system dynamics, which is really the mantos, so big flat-lying bodies, as opposed to the more chimneys, which are much more structurally controlled and more vertically oriented. So at Waterpump Creek, we see evidence of both mantos being overprinted by chimneys. So both flat-lying horizontal forms as opposed to more vertically oriented forms. So we see both of those. So yeah, the Warm Springs, Illinois Creek and Waterpump Creek, if you think of them as a spectrum, Illinois Creek is going to be hotter, closer to the source. We have a lot of sanding. We have gold, copper, silver. Waterpump Creek is just like the little fingernail at the very end where we have more silver, lead, zinc. So the alteration is going to be changing. The mineralization will be changing as we move from one side of the spectrum to the other. So we know things at Waterpump Creek and we know things at Illinois Creek. And so we expect it to be continuous as it should be. But what exactly the character and the nature of each part of that will be only revealed by drill holes.
If I could interject how that fits into our long-term strategy. So that was an excellent summary that Sage did. Warm Spring is an excellent target. Again, it takes drilling, and drilling takes money. So we decided to focus on drilling enough holes at Waterpump Creek at an adequate density for an inferred resource. So we're moving towards that. And that's just in that one area. So that should not be thought of as once something is announced that's the limiting factor. That's just that northern 500 meters of a 4-kilometer long structure. So ultimately, we'll continue exploring south, and when I add to that resource with the discovery and exploration at Last Hurrah, and then secondly, continue exploration from that Illinois Creek 1 and 2, those two little drill holes, and ultimately, we refer this internally as to our Hermosa style target, the Warm Springs target, and that would be analogous to the Hermosa deposit in Arizona that South 32 purchased a few years ago. Very similar geologic setting, and so that's what we're looking for there. It just takes a little bit of time to get there.
Thank you, Kit. We had a question on the geophysics and the target. We mentioning the 3 to 4 or 3 kilometer target at Waterpump Creek. Is that part of Warm Springs, or can I draw a box with the cursor roughly of our geophysics?
I'll let Andy talk about the details, but the geophysics we did this year extends north-south, and it does not cover the Warm Springs target. That'll be the next step. We're still learning about how the 3D IP works. We do know that it, now, compared to the original 2005 survey, it generated 10,000 data points, and our 3D survey generated 3 million data points. That was not fully I don't say understood, the implications of that and the computing requirements now have been achieved, but it just took weeks longer than we originally thought. Andy, you're the one that's looking at that most closely. If you'd like to
Yeah,
comment.
sure. That's a great explanation. Certainly with the survey this year, we really didn't, and we should have, but we didn't anticipate really what the computing requirements would be to do the 3D inversions on this 3D IP survey. And so one of the things we did is, we originally did have a plan to cover the Warm Springs target with that survey, but we scaled that survey back a little bit to ensure that we had enough drilling funds left to drill the last hurrah target. So that would be certainly a future geophysical target, would be to expand the IP survey to the south across the Warm Springs Fault, and then certainly also to the west to cover all of the ground, even further to the west of the Illinois Creek deposit.
Thanks, Andy. So just to confirm, this is the 3 to 4, probably, because this is at a 1 kilometer scale, so that being about 500 meters. So this is the Waterpump Creek and Last Hurrah targeting that we know with the geophysics. Okay, thank you very much for that. Okay, so thank you everybody for your questions, for your time. We're coming up on the hour here. If I missed any questions, I put my email address. It's Vanessa@westernalaskaminerals.com in the chat box. So if we didn't get to your questions, please, by all means, send it to me via email and we'll be happy to answer your questions. So there we have it. We have scale, we have grade, we have thicknesses. And Kit, do you want to have any closing remarks?
Sure. In the interest of time here, we'll make them short, but we're very encouraged with what we found this year. We want to do more drilling, and that's why we announced the smaller financing to extend the drilling season, that additional 1,300 to 1,500 meters, which will start on Friday of this week. So that'll be another month of drilling. We're very excited about that. The potential of having a maiden resource at Waterpump Creek in the fourth quarter of this year, I think will be really set a value floor under the company, because a lot of people want to see that type of number. We want to make sure everybody realizes that's just the first step of many future resources to come out of this deposit. And again, it's the scale is immense. It does take a lot of drilling, and so that's what we're working on. But we have an excellent team in place, and we have all the equipment in place. We had quite a few capital expenditures at the start of this year, new drilling equipment that is capable of drilling to the depths we need with large HQ diameter core, which will be great when we start doing more metallurgy testing. And we have everything in place for an excellent finish to this year and through September. And we have excellent plans laid for next year.
Thank you so much, Kit, Andy, Sage, and to our supporters, our audience. We really hope you enjoyed our presentation today. And again, Vanessa@westernalaskaminerals.com if you have any further questions. And with that, we are going to sign out. Thank you very much, everybody.
Thank you.
Thanks.